right, now we want to go on. The solution of an equation is called the root. Okay? Move some of this stuff out of the way. Pardon me, I'm trying to. The solution to an equation is called a root. You can find the root of the equation by examining the graph of its related function. A related function is found by solving the equation for 0 and then replacing 0 with f of x. Okay? So if you take any equation like this, 2x plus 13 equals 9, all we got to do is subtract that 9 over. What's 13 minus 9? It's 4. So then f of x equals 2x plus 4. That's all a related function is, guys. Don't let it be confusing. And here's what's cool. When we know what an equation is, we set it equal to 0 on purpose so that we could solve for it. So when we put that, we graph y equals 2x plus 4, you'll notice when it's equal to 0, that is at negative 2. And what is negative 2? It is the solution of 2x plus 13 equals 9, right? We could solve that out. We could subtract 13 over. We get negative 4. Divide both sides by 2, x equals negative 2. So it's the solution. Negative 2 is also the root. It's where it crosses the x-axis. It is also the 0 of the function. In other words, if I plug in negative 2, 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. It's the 0 of the function. It is also the x-intercept of the function. So negative 2 is a lot of things, right? And this is how we find it. It starts with subtracting whatever on the right side, setting the equation equal to 0, and replacing 0 with f of x to get the function. Awesome, good stuff. You will see related function. Again, whenever I give you an equation, I say, what's the related function? Just subtract whatever's on the side over and write it down as f of x equals that, okay? We're just touching on that a little bit, but it is something you will see. Okay, solve. 9x plus 6 equals 12x by graphing, okay? And which is the graph of the related function? So I'm just going to subtract 12x over. So when I subtract 12x over, what do I get? Minus 12x. And 9x minus 12x is negative 3x, and then it's plus 6. And I'm going to say, all right, f of x equals negative 3x plus 6. And this is in mx plus b form, so we're looking for a start value of 6 and a slope of negative 3. Okay? Negative slope, remember, negative slope goes down from left to right. Positive slope goes up from left to right. So we're looking for one with a negative slope. So right away I can say this is wrong, this is wrong. Those are positive slopes. In fact, this is a positive slope. I can tell from that little bit. The only negative slope is d. Let's see, though, if it has a start value of 6 and a slope of negative 3, okay? So let's see, start 1, 2, 3, 4, 5, 6, there we go, and down 1, 2, 3 over 1, look at that, a slope of negative 3. So it is indeed D. Look at that. All right, let's get moving on. Okay. In Luis's school district, high school students are required to complete 100 hours of volunteer community service to graduate. If Luis volunteers 12 hours a month at his local food bank, then V equals 100 minus 12 times M represents the number of hours that Luis has left to volunteer V after M months. So he's doing 12 hours to month. So let's say he does 8 months, it's 96 hours. 100 minus 96 means his V, he has 4 hours left. Okay? Use the graph to estimate to the nearest tenth the number of months that Luis must volunteer to meet the requirements. Okay, when I'm looking at this, between 8 and 9, that looks about 8.3-ish, 8.3 or 8.4-ish. So I think 8.3 months. It says nearest tenths. Okay? Look at that. And the truth is, you can guess anything pretty close to that will be fine when you're guessing things. Solve algebraically to verify your estimate. Round to the nearest hundredth. Okay, so I want to know when this is going to equal 0. If I want to know when V equals 0, right, then I'm going to have 100 minus 12M. I'm going to set it equal to 0 instead of V because I want V to be 0. I forgot my M. So I need to subtract 100 from both sides. Minus 100. And I get the negative 12M equals negative 100. This is good. It's going to turn out to be positive. Watch. Divide both sides by negative 12. What do we get? Our m equals, let's see how we did rounded to the nearest tenths. 100 divided by 12, or negative 100 divided by 12 is about 8.3. Look at that. I was right, y'all. First time through. All right, so it comes out to 8.3. Again, write that down, record it. So it's going to go, gone. So we have 8.3. Oh, it said 100, so that'd be 8.33. Excuse me. And there we go. Awesome. Good job. Okay, let's go on to the next slide. Okay, looking at this one, we're going to solve a linear inequality. So now we're going to throw inequalities in the mix. Notice we're just doing a lot of linear equations. Now we're just going to do inequalities. I'm going to treat it the same as long as we don't divide by a negative, guys. It's the same. If we divide by a negative, we just flip the sign. So whenever I see a fraction covering everything like this, I'm going to multiply everything times the number to get rid of the fraction. In this case, times 3. And I've got to distribute it, right? When I distribute over here, though, it's just simply going to be times 3. And it's going to cross out just that 3 down there. So I'm going to be left with 12 times negative r plus 1 equals negative 48. Okay, now let's distribute this 12. So I'm going to have negative 12r plus 12 equals negative 48. All right, we're getting there. Let's subtract 12 from both sides. Those will just add together, right, because they're both negative. So I get negative 12r equals negative 60. I keep writing equals, but it should be greater than, shouldn't it? Greater than. Greater than. I just get used to that equal sign. And I'm going to divide both sides by negative 12. Uh-oh, we're dividing by a negative. What happens? We flip the sign. So now I'm going to have r is less than, negative divided by a negative is positive, and 60 divided by 12 is 5. So r is less than 5. So it should be an open circle pointing to the left of 5. I'm going to erase this, 3, 2, 1. Looking for 5, open circle, right there, pointing to the left. Boom, because each goes up by 2, so that's 5. This is most definitely B. Sweet. Good work, y'all. Always got to reset it. Otherwise, like I told you, I go to teach it. Okay, our last slide of the day. It's been kind of a long lesson, but there's a lot of ground we're covering. Shelby uses social media for the same number of hours each weekday, in addition to 3.5 hours on weekends. She wants to decrease her weekday usage so that her total time for the week spent on social media is less than 6 hours. Which inequality could be used to find the number of hours Shelby should spend on social media each weekday in order to lower her usage to less than 6 hours per week? Okay, there's 5 days a week. So, each weekday, in addition to 3.5 hours on the weekend, she wants to decrease her weekday usage so that her total time for the week. Okay, I thought it didn't. So this includes the weekend. So we're going to need to subtract 3.5 hours, right? So we're going to need, so that means we're going to be spending 5 days a week times H hours, right? And we're going to add to that 3.5 hours because we're doing 3.5 hours on the weekend. And we want that total to be less than 6. Ooh, look at that. I see it right there. Boom, it's C. How many hours should Shelby use social media each weekday in order to spend less than 6 hours using social media per week? Okay, now we need to go solve this equation. So let's solve it. Again, we're just going to subtract 3.5 from both sides. It actually is minus 3.5, which is going to be 5h is still less than, what is that, 2.5? And we need to divide both sides by 5, which 2.5 is half of 5. So that means she needs to spend less than 0.5 hours, right? The hours need to be less than 0.5. So she needs to be spending, let's go away with that. H should be less than 0.5 hours. Look at that. Awesome, guys. Well, that's it for today. Hope you're all doing well. With that said, peace out.